question 1a, the question asks to estimate the change in the value of function of f when values for x, y, and z changes from point P to point Q. First, we know that formula for estimate of the change is dw equals to fx ds plus fy dy plus fz dz. The question already given the function of f in terms of x and y and z. Therefore, we just need to find fx, fy, and fz. From the question also, we know that the changes is from point P to point Q. So from that, we know the value for dx, dy, and also dz. The initial value from the point P is the initial value for x, y, and z. After we obtain all the information that we need, we just plug in into the formula and we just substitute all the variables with the values that we obtained just now. So after we plug in and substitute all the values, we get this for final answer. Next, for question B, this question asks us to show if this function is the same as the equation below. So first, we need to find the value for zx, which is the same with delta z over delta x, and then we find zy, which equal to delta z over delta y. After we got delta z over delta x and also delta z over delta y, we just plug in into this equation. We will get the same answer with the equation shown above. Okay, next for the last question, for question 1, the question already given, it is a rectangular box without its top cover, and the volume for rectangular box is 32 meter cube. We need to find the dimension of the box to make the total surface area is minimum. And lastly, we need to show that the dimensions satisfy the local minimum properties. First, I draw this rectangular box to make it clearer, and I jot down all the information given. We know that the volume is 32 meter cube, and the formula for volume is length times width times height. So we got P times T times L is equals to 32. And then we let L is equals to 32 over P times T. Next, we need to jot down the formula for total surface area. Then we got P times L plus 2TL plus 2PT, which we got here in this figure. P times L, which is here, it is just one surface because it has no top cover. Then we got 2T times L, which is here. It has two surfaces, so we need to multiply with 2, and plus 2P times T. Here, it is also have two surfaces, so we need to multiply with 2. After that, we substitute the values for L with the value that we got earlier, which is 32 over P times T. Then we got this for the last equation for total surface area. Next, we know that to find the dimension, we need to find the function with respect, derivative with respect to P and the derivative with respect to T, which is also known as delta A over delta P and also delta A over delta T. So from the equation that we obtained just now, from this equation total area, so we find AP and we got this equation, and also next we find AT and we got this equation. Next, we double differentiate it with second order. So we have this as the equation and also this. Then we let the derivative with respect to P equals to 0 and the derivative with respect to T equals to 0. So we need to do the simultaneous equation, and we got P equals to 0 and P equals to 4. Then we need to find the value for T, so we just substitute the value of P into the equation and we got T equals to 2. So now we already got the critical point, which is 4 and 2. Then we know that the formula to find local maximum, local minimum or saddle point is G equals G in terms of PT equals to APP ATT minus APT squared. So we already obtained APP, ATT and also APT. We just plug in into the equation and we got this for the function of G. Then we just find the value for G when the value for P and T is 4 and 2. So we got G equals to 12, which is more than 0. Then we also substitute the value P and T into APP. Then we got 2, which is also more than 0. These both values are the properties for local minimum. Therefore, we got A42 equals to 48 is a local minimum. And the dimension for the rectangular box is P equals to 4, T equals to 2, and L equals to 4.
Question 2. The question asks evaluate this equation in first changing in polar coordinate. We must turn it to polar coordinate form. First, we find the limits for x and for y. For y, the limit is y equal to 0 and y equal to set 2. And for x, we got x equal to y and x equal to set 4 minus y square. From this, we can come it x square plus y square equal to 4 is equal to square. 2 means radius for this xy circle. Then we draw the circle in x, y, and x axis. This one is circle with radius of 2, and then this one is x equal to y. The limit for y is 0 to set 2. So this one from the polar coordinate, theta is 0. For this one, picture R1 is all of this, and the R2 is the small one. To find R, where the R is equal to R1 minus R2, we know that x square plus y square equal to R square, and dA is dx dy is equal to dy dx equal to R dr d theta. For R1, where the radius is 0 to 2, integrate 1 0 and integrate 0 pi over 4 1 over 1 plus r square r dr d theta. Then we integrate it, become ln 1 plus r square over 2, and this is the limit. Then put the limit in the equation. Then we got this. Then we write this one with respect of theta. Theta ln 5 over 2 is equal to 5 over 8 ln 5. This one is the answer for R1. For R2, the radius is set to 2. We got this one. Integrate R, then will become ln 1 plus r square over 2. This one is the limit for R, and we integrate respect to theta. We got theta ln 5 over 2 minus theta ln 3 over 2, and we got this, and this one is for R2. Then to find R, where the region is R is equal to R minus R1 minus R2, and we got this one. R1 minus R2, we got this, and this is the answer. Question 2b, evaluate the integral, this one, where the first octant z equal to 4, x squared plus y squared equal to 1, and cylinder of x squared plus y squared equal to 4. This one is the radius of cylinder 1, first cylinder, and the second cylinder is if r is equal to 2. So we draw the cylinder, first cylinder with radius of 1, and the second cylinder with the r radius is 2. The limit for z is equal to 4. This one is first octant. Cylindrical coordinate for this one, we get triple integral fr theta z dv is equal to triple integral fr theta z dr dz d theta r dr dz d theta. And this one is the limit for z, r, and theta. Z, the limit is 0 to 4, and for r, the limit is 1 to 2, and for the theta, 0 to pi over 2. Theta is the angle at x and y axis. The limit grade integral 0 to grade. This one is the limit, this one is the limit. Okay, integrate with respect to z first. Okay, first we know that y is equal to r sin theta. Substitute y into r sin theta into y square. We got this one, and then we integrate respect to z. We get respect to r and respect to theta. We got 55 over 4. That's the answer. For the C, evaluate this by first changing it to spherical coordinate. First find the limit where x equal to this one and this one, where x equal to 0 and x equal to negative 1. For y is 1, z, and that one. For this one, y is equal to 0, y is equal to z, 1 minus x squared. For z, we got z is equal to 0, z is equal to z, 1 minus x squared minus y squared. We got z is equal to x squared plus y squared is equal to 1. We got y with 1, r radius with 1, and that one is a sphere with y is equal to 1 radius. This is the region with the full the limit. This one is on z axis, where from positive 0 to pi. And we know that x is equal to rho sin that cos theta, square sin theta is now d1 d rho that one and d theta. X square plus y square plus z square is equal to rho square, and z is equal to rho cos fish. And this one is the question of spherical coordinate respect to rho. We substitute we let u is equal to rho power of 3, and du d rho is 3 power of 2. 3 exponent power of 2. A row of 3. And we got du d row is equal to 3 row power of 2. We cancel this one with this one, and we get this one. Then second integration with respect to this one, we get this one, and then we put the limit. And for the third integral, we do it with respect to theta, and we got negative theta exponent power of -1 plus theta. Got this, and this is the final answer.
Now, given the vector valued function Rt, find the position vector, unit tangent vector, and unit normal vector. First, we need to find the position vector at t equal to pi. So we simply substitute t with pi at the equation of r. So we will get pi cos pi plus pi minus pi sin pi, pi minus 1. So we will get negative pi, pi, pi minus 1. So this is the position vector at t equal to pi. And for the unit tangent vector, we need to find the tangent vector first. Tangent vector equal to differentiate of position vector. So we get negative pi sin t, negative pi cos t, and 0, and so on. So we use the unit vector function, which is the vector divided by the magnitude of the vector. So we will get 0, 1, 0. And for normal vector, unit normal vector, we find the normal vector first. We differentiate tangent vector to get normal vector, and we find the magnitude of the normal vector, and simply use the formula of unit vector, which vector divided by magnitude. We will get 1, 0, 0. For question B, find divergence of f. Divergence of f is equal to del dot f. So we use the dot product. Okay, so we will get delta f1 with respect to del x, and so on. So we will get this one. Now, to find curl f is just like divergence, but this time it is cross product. So you cross product the del with the function or the vector f. So we get like this. This is the final answer. Now for the del of the del dot f, del dot f means divergent f, which we already calculated at the question bi. So we just take this as a function of phi. Okay, so I take it as phi, and now let phi equal to divergence of f. So you remember, if del phi means gradient of phi, right? So we simply use this formula. Okay, differentiate the function with respect to s, differentiate the function with respect to y, and differentiate the function with respect to z, and finally you will get this as the answer. Now for the question 3c, find the directional derivative at point q in the direction of vector c. Now you are given the direction of vector. The formula of directional derivative is del phi dot with unit vector. Now if you are given vector, find the unit vector of the vector first. So the magnitude of the vector c is 3. Now the unit vector is vector divided by magnitude. We will get this. Okay, now we do the dot. Okay, before that we find the del phi first. We find the gradient. So we differentiate the function phi with respect to x. We will get this, and so on with respect to y, with respect to z. We'll get the function of this. And finally we will get this is the del phi. To find the directional derivative, we use the dot product. Okay, so dot product del phi with c, which is this one. So negative 2 over 3 multiply with e exponent minus 1 over 3 multiply with 3 pi minus 1 multiply with 2 over 3. So we will get this as the final answer. Now, hence, find the maximum rate of change. To find the maximum rate of change, we simply take the magnitude of del phi. So this is del phi. We get the del phi here. Find the magnitude of it. So exponent squared plus 9 pi squared plus 1. So we can calculate this as how we want to calculate the exact value. We will get 6.055. Now, to find the direction in unit vector, you take the del phi divide with its magnitude, which we already calculated. So you just substitute. This is the function, the vector of del phi. This is the magnitude. So we will get this as our final answer.
The next question is question 4. For question 4a, the question asks to evaluate the line integral. So the solution will look like this. Integration of f dot dv is equal to integration of elements of f dot elements of dv, which is we will get equal to integration of f1 dx plus f2 dy plus f3 dz. So the question gives the RT, so we can find R, which is t squared, 4t and cos t. So dr is actually the differentiation of R, so dr is equal to 2t, 4 and negative sine t. So f is equal to x squared cos y and 4yz. So the integration of x squared dx plus cos y dy plus 4yz dz, we substitute the x is equal to t2 and y is equal to 4t and z is equal to cos t. So in order to find x prime, y prime and z prime, we need to differentiate all of the x, y and z, which we will get x prime is 2t, y prime is 4, z prime is negative sine t. So it is equal to the integration of t to the power of 4 times 2t plus cos 4t times 4 plus 4 times 4t times cos t times negative sine t dt. So we will get 2t to the power of 5 plus 4 cos 4t minus 16t cos t sine t. So actually we can simplify this using trigonometric identities. So actually 16t cos t sine t is equal to 8t sine 2t. So we'll get like this. So after we integrate the two elements in front here, we will get 2t to the power of 6 over 6 plus sine 4t. But for the negative 8t sine 2t, we need to use the integration by parts using tabular method. So after we do the integration, we will get 4t cos 2t minus 2 sine 2t, and then we plug in all the values, which is t is from 0 to pi. We will get pi to the power of 6 over 3 plus 4 pi. For question 4b, the question asks to show that f is a conservative force field and find its potential function. So first we know that curl f is equal to gradient cross f. So f from the equation we know that f is equal to 6xy cubed plus 2z squared, 9x squared y squared and 4xz plus 3. So after do the cross part for elements I, is del over del x and 6xy cubed plus 2z squared. For element j is del over del y and 9x squared y squared, and for elements k, del over del z, and 4xz plus 3. So after do the cross part, we will get here is del over del y times 4xz plus 3 minus del over del z times 9x squared y squared for elements of I minus del over del x times 4xz plus 3 minus del over del z 6xy cubed plus 2z squared for j elements, and plus del over del x times 9x squared y squared minus del over del y 6xy cubed plus 2z squared for elements of k. So after solve the things in the bracket, so it will get 0. Value is 0, so it is shown. So to find the potential function, f1 is equal to del phi over del x, and which is equal to 6xy cubed plus 2z squared from equation. So f2 is actually the del phi over del y is equal to 9x squared y squared. f3 is equal to del phi over del z equals to 4xz plus 3. So in order to find phi, we need to do the integration for each element. For element f1, we integrate 6xy cubed plus 2z squared with respect to the x. So we will get here 3x squared y cubed plus 2z squared x plus c1. And for element 2, we will get 3x squared y cubed plus c2 xz. So for the integration, the third f3 is we will get 2xz squared plus 3z plus c3. So the final answer, phi is equal to 3x squared y cubed plus 2xz squared plus 3z plus c. So next question is, using the potential function, find the work done by f at these 3 points. So since the question gives us 3 points, so we need to divide w which is equal to w1 plus w2. So w1 is actually integration of f dot dr for limit from p to q. So for w2 is equal to integration from q to r of f dot dr. So here w1 is equal to phi points here, points q 1 2 3 minus phi point p which is 0 1 2. So we will get for w1, we plug in the value, so w1 we will get 45. For w2 is equal to phi point r minus phi point q. So after plug in all the values, we will get negative 24. So for the work done, we plus w1 and w2, we will get 40 minus 24 which is equal to 21. Next question is for C. For C, the question asks to use Green's theorem to evaluate these functions, where C is the boundary of the region bounded below by y equal to x and above by this circle. So the solution will look like this. As we see in the question, we can find that f1 function 1 is equal to cos x squared plus xy squared minus 4y, and for function 2 is here is equal to sin y squared plus x squared y plus 2x. So next, in order to fulfill the requirement of Green's theorem, we need to differentiate f2 with respect to x, and then we will get 2xy plus 2. We also need to differentiate f1 with respect to y, and then we will get 2xy minus 4. So here is the equation of the Green's theorem, which is double integration of del f2 over del x minus del f1 over del y dA. So after that, we will get double integration of, we plug in the value here, the function here, 2xy plus 2 minus 2xy plus 4 dA. So we solve the things in the brackets, and we will get double integration of 6 dA. So we convert the dA to r dr d theta. So here is the sketching. The sketching is here is y equal to x, and this is the circle x minus 1 squared plus y squared is equal to 1. So we can find the limits for theta, which is theta is equal to from pi over 4 to pi over 2, and the radius is equal to r. The r is equal to 0 to 2 cos theta. So here after we put the limit here, so after the integration made, we will get integration with respect to r, we will get 3r squared. We need to put the limit here, and after we plug in the value, we will get 12 cos squared theta. Then we integrate the 12 cos squared theta d theta. And first, actually, we can simplify this, which is 12 cos squared theta, which is actually 6 1 plus cos 2 theta. So the integration of 6 plus 6 cos 2 theta, we will get 6 theta plus 3 sin 2 theta, and we plug in the value of theta, which is from pi over 4 to pi over 2, we will get 3 over 2 pi minus 3.
I will show you how to solve this question 5 for this final year class test. Evaluate the surface integral, which sigma is the portion of the parabolic cylinder z is equal to 5 minus x squared that is bounded by the plane x is equal to 0, y is equal to 0, z is equal to 0, and y is equal to 1. First of all, we draw. X is bounded to 0, y is bounded to 0, and z is bounded to 5, and this is set 5. Yes, we draw same with what the question needed. Second, you find the shadow of the plane, because this is a 3D. From the formula, to evaluate this, we find the shadow first, and I took this base as the shadow, xy plane. Now, after that, we find function z. Function z is equal to function g x y, which we can get it from here. Z is equal to 5 minus x squared, z is equal to 1 square, and find vector f, which is, we know this is I use type 1, condition 1, which is z minus function z here, minus is equal to 0. This is the condition. Now find ds. ds is equal to direction f times with dA. Direction f, we know we can find it from here. Function to the x, differentiate to the x, differentiate to the y, differentiate to the z, which is the same function of s, f, which is here, and you will get it something like this. Actually same with function of x. Function of x, if we differentiate to the x, we will get 2x. If we differentiate to y, we will get 0, and differentiate to z, and we will get 1. So just substitute each value to here, to this formula. After that, you will get direction of f is equal to negative 2xi plus k. Now, to find ds, as is stated here, you need the magnitude of this value. The magnitude of this value is shown here, and you will get it here. Now, just times with the formula. This formula, we change value of z as the function of here, and we also managed to get the value of ds here. We just substitute it, and you will get here as the result. dA, what is the value that we want to put at the sigma, which is dA as we took it here. So I use type 1, this is rectangle, is the numerator, type 1 on type 2, just click it here. Y is limit to 1 to 0, and x is to the limit to 0 to set 5. And then, as you mentioned, I stated here, make sure that you put the value is correctly. dy, and you will get here, same, dx, this is the final result. Now, we go to question 5b. Use Gauss theorem to evaluate ini is equal to f function vector of this, and net n is a unit normal to the outward orientation of sigma, the surface of solid bounded by cylinder, the plane z, and paraboloid z is equal to 1 minus x squared minus y squared. Okay, first we draw. We list all the things that given by the question, and we also know that this formula is same with this formula. Dimension of vector f. Now we draw the paraboloid, the equation of paraboloid, we draw it here, and the equation of cylinder with the limit of z is equal to 5. Yeah. Now after we draw, we find the dimension of f first. Use this formula, we already know the product of this and function f, and we will get it here. Now we need to find two types of volume. First, volume of cylinder, and second is the volume of the cylinder first, which is I list the limit here. Z is equal to 5, 0 is height, is radius from this area, from this circle area 0 to 1, and we know that the angle of this circle is 2 pi, from 0 to 2 pi, and this is the function that we got from the f, which is here. We got it here. From here we know that x squared plus y squared is equal to r squared. We change this because this is a cylindrical formula to find this volume, and you enter all the value and you will get 30 pi. And next we find the volume of paraboloid, which is we use the volume of sphere surface, which is dp, d delta, and d pi. I'm sorry for this, but this is actually d phi, and we know that this is from 0 to 1. The angle is equal to 0 to 2 pi, and d phi we look from z-axis. From z-axis, from here until here, and we know it is actually 90 degree of 90%. This is the direction of f that we got it here. R is equal to P sine phi, and we insert all the value into this formula that we learned from chapter 4, and final answer we will get here. This is the volume of parabola, but we want to find the bounded value, which is between the parabola and the cylinder, so we need to subtract. So this is the actual volume of the bounded region. Let's go to answer question C, which is top theorem to evaluate this function, this vector, and C is a line of the plane x, y, z is equal to y, lies in the first octet with the orientation counterclockwise looking from above. Evaluate, list all the value, the hint that given from the question. Next, you sketch the region. Since each region at the first bounded by the first octet, so it will become like this, and n is on the positive value. So we also know that formula same as this function 1, function 2, function 3, which is from this formula is given f1 is equal to 2x plus y square, f2 is equal to y plus z square, f3 is equal to 2z plus x square. And now we just need to find this f is equal to dot dr is also equal to same with the direction cross product with f dot product with n vector times with ds. So to find this triangle product cross product with vector function, we insert it into formula. We know, we learn I we get with negative 2z, j we will get negative 2x, k we will get negative 2y, and we also know that phi is equal to x plus y plus z. So manage magnitude of pi is equal to 1, 1 and 1. From where we get this? From here. This is same with the previous question. Z is equal to 1 minus y minus x is given. Z differentiate to y, we will get negative 1. Z function of z differentiate with x, we will get to negative 1. And next we will insert to this. Since it is positive, it is actually negative, so the negative is cancelling each other. So the magnitude of phi we will get Z3, and here we will get vector of n or normal line. So we get from this also, we put it to find value of ds, value of ds time with dA, and we will get Z3 dA. And next we look at the shaded region, which is I took it from the xy plane, and now we solve it as what we learned from chapter 4, which is we put it first, this equation that we get from here. This value we know, and also this value also we get it. This value and value of n, we put it all in the formula, and then we just solve it like what we learned from chapter 4. Yeah. And the final answer we will get is Z3/9.